Awesome. Hello, everybody. Welcome on the last day of Ignite. Thank you for joining us towards the end of the show. This is fast and flexible inference on open source AI models at scale. I'm Cary. I'm Senior Product Manager on Azure Container Apps.
Hello, everybody. This is Mehrdad. I'm Principal Cloud Engineer of Royal Bank of Canada, leading AKS platform.
And I'm Sachi. I'm a Product Manager on the Azure Kubernetes Service team.
Yeah, and we're super excited today to be talking with you guys about open source models and running inferencing for open source at scale. So with that, let's get right into it. Let's see. All right, so today, there's a few things we're going to be covering. So I'm going to lead off here with a quick introduction just into the current landscape of open source, what we've been seeing from customers, what we've been talking about, and also just developments in the space in the last year. Then I'll also go into running instant serverless inferencing with serverless GPUs. So this is going to be the Azure Container Apps section. And then I'll hand it off to Sachi and Mehrdad for running with flexibility on Kubernetes using 𝗦𝗲𝗀𝗀𝗀𝗀, so being able to run these open source models at scale with all the flexibility that you need for your compute. So open source models. In the past year, it's been an exciting time for these models, right? I guess most of you guys have probably seen some of these. Maybe DeepSeek, maybe GPT-OSS have made some waves. Honestly, show of hands real quick. How many of you guys are surprised that it's been less than a year that DeepSeek has been out? I know I have. It's been a crazy year. It's been a long one. But yeah, it's been a really amazing year for open source. It's been an explosion of open source models into space. There's llama 4 setting a new bar for reasoning and tool use. Gamma 2 delivering high quality lightweight models. DeepSeek, as we mentioned, really kicking off that wave. And GPT-OSS just recently with matching 𝗬𝗲𝗏𝗏 mini and 𝗬𝗏 mini performance on an open source model. And honestly, open source models that run on T4 and single GPU A100 GPUs. So it's been a super exciting time for open source. But with all these improvements still, right, why would you choose to run open source? LLMs are super powerful, right? They're super good at what they do. But there are some reasons that you should be looking into open source for your applications and for your platforms. So the first one is saving on inferencing cost. So that one's easy, right? We all like money. We all like to save some money where we can. At least I do. I don't know about all of you. So by running your own models, hosting your own models, you can save on some inferencing costs for your applications, right? Instead of paying per token all the time, you're paying per GPU, but you're doing that a little bit more in-house. You also get fast and flexible, speed and flexibility, basically. Being able to basically move as fast as the market is moving, right? As I mentioned this last year, there's been a lot of developments in the open source space. And it's honestly been a little bit hard to keep up even at times. But by being able to run open source models, deploy them, you're able to be at the cutting edge of that technology and move quickly alongside with it. All of this as well with being able to run multimodal, multi-cloud solutions, right? When you're running open source, that means that you're building your own solution on your own platform. And you're able to take that and you port it over to other platforms, other products, and other clouds as well, right? So if you are a multi-cloud shop, instead of having to build a different solution for every single cloud vendor, you could build the same solution, containerize it, and deploy it, right? And then last one here, and this is honestly one of the biggest ones that I've been hearing about. How many of you guys here work in a sector like, finance, government, or, medical, right? Quite a few of you. One thing that's super great about being able to run open source models on your own compute is that you get to control that data quite a bit more, right? So you get data privacy, you get governance, and that data does not leave the bounds of your applications, which is huge. Oh, there's a pop. Oh. Okay. Now, some use cases as well with open source and LLMs. Agents have been all the rage, so we decided to make the other box bigger. So summary analysis, hybrid models, right? There are a lot of use cases where we've been seeing with customers where they do run both LLMs and SLMs, right? They'll run the large language models, more of an orchestrator, and then have smaller language models handling more of that proprietary data, running it within their environment, and making sure that they keep that segregation of boundaries so that their data is never going out towards a separate API, a separate entity, right? And of course, agents, I'll give you guys a demo on that later. You guys have been hearing about it all week, so we won't go into that too much. Oh, I think I clicked too much. Not enough. All right. Okay, so that brings us to what are we talking about here today, right? That's introduction. We're really focused on Azure Container Apps and Azure Kubernetes Service today. These are two great platforms for running containerized applications in Azure, and they're great solutions for building your open source solutions in Azure as well. We're leaving out Foundry a little bit today just because we're talking about containerized open source. Okay, so deploying SLMs on serverless GPUs in Azure. So Azure Container Apps. How many of you guys here are familiar with container apps? Maybe a few, quite a bit. Oh, that's a good number. I like that. Okay, I won't spend too long on that slide then. So container apps is awesome because it's a serverless containerized solution, right? It's meant to be so that you can have the easiest way possible to deploy your containers in Azure without having to worry about infrastructure, without having to worry about management, operations, things like that, while also still getting instant event-driven scale to zero containers. We talked about money earlier. You're also paying per second and hopefully saving costs, right? With container apps, there are a variety of use cases. Just about any application that you can build that is a containerized solution, you can deploy to container apps, right? So microservices, event-driven containers as well as backends, and of course AI apps and agents, right? And again, container solutions, so all of these scenarios that you're seeing here are also applicable to AKS, right? You can deploy these to AKS as well. And in container apps, we have quite a few different types of compute now. So we have apps. These are your classic long-running containers that you're going to be wanting to handle long-running tasks. And then there's jobs, which are more event-driven. You can trigger them based off timers, queues, scalars, whatever. We also have dynamic sessions. This one is a little bit more new. In terms of the compute that we have. Dynamic sessions, we have code interpreters, and they're basically sandbox compute, so you're going to be able to run untrusted code within that container securely, right? So you can imagine even like if you had an AI agent generating code, well, you don't want to run that in your application, your core business logic, right? But in a safe sandbox environment, that's pretty nice. We also have, as of this last year, a serverless-based compute platform, right? So we have serverless GPUs for apps, jobs, and we actually have it in private preview for dynamic sessions as well, if that is something people are interested in. So serverless GPUs. I've talked a lot about the benefits of container apps. What's awesome about serverless GPUs is you inherit a lot of the same benefits, right? It's the same exact platform. We're still pushing the same product. So you're getting the scalability, you're getting the pay per second pricing, you're getting the ease of use, not having to do a lot of infrastructure management. And as well, like I talked about before, what's core about open source models, data privacy and governance, right? We have all the enterprise security features that you're going to need. And when you're using an open source model on container apps and serverless GPUs, that data is never leaving the boundary of your environment unless you so choose, right? Now, for use cases, I'd say actually about 70–80% of our customers that are using serverless GPUs right now are doing some sort of inferencing. So whether that be chat completions, image generation, what have you. That's probably about 70–80%. Aside from that, fine-tuning of SLMs, other ML workloads, probably around 10% or so, and then remaining there is high throughput computing and data analytics, right? So you can imagine physics engines, video processing, things like that. Okay. So I did want to share and shout out one of our customers that we've been working with in this space on container apps, 𝗦𝗽𝗀. They're a startup based out of Paris, and they're really big into the upcoming fashion AI industry here. So they've been working on creating stunning studio quality fashion images and videos from basic product photos instantly and affordably, right? So they're using a lot of generative AI models, and you can see the rest of their webpage. And we also have here a video of their product in action, right? So you can see picking different styles, picking your model, and then being able to see what that outfit looks like in the end there. Yeah, so they've been having a great time with serverless GPUs. in terms of a flexibility to be able to deploy any of the custom AI models that they want, any inferencing server that they find. So anything from Hugging Face and beyond. And then they're able to move quickly with that as well, right? Because they're not relying on some other cloud provider, supporting that model first. They can just go ahead and they can say, hey, I want this container. I'm going to containerize it, and I'm going to go deploy it on my own compute. And of course, the scaling, right? So being able to dynamically scale based off your workloads for your GPUs, it has been key for them as well. And here's just a quick look at 𝗦𝗲𝗀's architecture. So what they have here is a backend client. So their customers are coming in basically, and they have almost like a orchestrator, a gateway of sorts with an ACA inference API. And then that application is basically dictating what other applications are spinning up and what types of open source models are running, right? So they have here the imprinting worker, generation worker, and then they have a bunch of other AI workers all within this catalog, and they're able to run on CPU, GPU being A100 and T4 compute as well. So they've been having success with that. For announcements, we do have a few things here. So one, MCP dynamic shell sessions. You might have heard me mention dynamic shells earlier today. So these are fully isolated ephemeral environments, run untrusted code in milliseconds, and it's secure sandboxes for your AI workloads, right? And now we've added MCP on top of that for a shell container code interpreter, so you can use that for any of your workloads that you're building with AI agents. We also have Docker Compose for agents on Azure Container Apps. Just curious, how many folks here are using Docker Compose today or have used it in the past? Okay, nice. So yeah, we're making it easier to make your local developments with AI applications and agents and port them over to the cloud, right? So turnkey deployment of agents, models, everything that you need to get your applications created without having to worry too much about the infrastructure provisioning side. So with that, we're going to switch over to a demo. What I built and we'll be sharing you guys today is an agentic dashboard generator. So pretty straightforward in terms of a number of applications here. We just got a front-end application running on consumption compute. We have an agent service as well that's running on consumption. And then we have a 𝗦𝗲𝗀 application that is running on an A100 GPU within the environment. So let's switch over. Let me make that bigger. Okay. So here we have our application code. We've built this using Microsoft Agent Framework. So you can see we have some tools here with like a deterministic CSV profiling surface for our Microsoft Agent Framework tools, as well as other things. And here we also have our infrastructure. So we have our bicep code, all the JSON that is needed to attach that to our applications, as well as our Azure YAML. So what that means is our application is fully AZD upable, right? We run AZD up, all the infrastructure gets provisioned, all the applications get provisioned, everything just links up. Now, if you didn't want to worry about the infrastructure, right, you could also run now the Docker Compose for agents, and you would be able to spin up this whole thing in one command as well, only worrying about your applications instead of any of the infrastructure there. But with that, we have, let's jump straight into the portal here. And you're going to see here, we have our applications. We have our agent, we have our front end, and we also have our 𝗦𝗲𝗀 application. You're going to see a few other applications here. I meant to go delete them, but then, 5 minutes before the demo, decided it was probably not a good idea. We do have those 3 applications. Don't get confused by the other 2. And we're going to take a look into here into what these applications can do. So we're going to go ahead and we're going to actually go and kick off our front-end application. So that's going to be spinning up, not immediately available, scaling from 0. And then we're going to go and actually take a look at some of our capabilities and features that we have in Container Apps. So one thing that I really love to do when I come in is I love to go to log streaming. It's just super great, super easy to view and see what is basically going on in your application, right, in real time. So we're going to spin up our log streams for each of these applications. Okay. And like I said, almost deleted stuff beforehand, decided it was not a good idea. Okay, so this app is spinning up, and while we're doing that, let's actually take a look at some of the other pieces of container apps and what makes container apps, right? So we have our container app environment, and a lot of you guys are familiar with container apps already. This is serving as your security, your networking, your observability boundary, right? So all the applications here will share networking features, as well as any identities that you're setting, security features that you're putting in place. They will all benefit, right? So if you're trying to build your AI applications, you're trying to build agents, you're trying to build microservice applications within the container app environment, you're going to be able to spin up the environment itself, integrate that with a VNet one time, and all of the applications inside will be able to benefit. Now, with that, I've stalled long enough, so we'll go to our front-end application here, and we will go ahead and hit that with a CSV file. So what's happening now is it's going through, and the agent orchestrator is deciding what tools it's going to pull and which ones to use, and then that's going to go ahead and parse that CSV, decide what charts to build, and then go ahead and build us some dashboards. So this is running. And we can see here, like I said, log streaming is kind of nice. You get to see what's going on here. So if we look into our 𝗦𝗲𝗀𝗻𝗂 application here, we have quite a few logs coming through now. And they are all coming through. Let's see, actually. OK, so here we have, this may take a while. OK, but yeah, so container apps is great because you're deploying all of your Linux-based containers, right? Any container that you have, it's flexible compute. You're able to provision it and run it on the application, all while being able to customize, scale individually, and compute for each of these as well, right? Which is important for AI applications because you're going to be having different needs for each of your applications, right? So you can see here in our environment that we have a front-end app, we have 𝗦𝗲𝗀𝗻𝗂, we have the agent, as I mentioned before, right? And if we actually go to our environment here, we can see that we have a few different workload profiles set up, right? So we have consumption, and we also have our GPUs here, right? So the applications that don't need the GPU, they're all able to run on a consumption profile. They're able to run on CPU. You're saving costs there, while you're being able to run all the GPU applications, of course, on an A100 or a T4 GPU within the environment. OK, so we are still waiting here. OK, perfect. So we see we have hit an error here, actually. So let's go back, and we can monitor that and see what's going on here. It looks like our agent here didn't actually handle the JSON great for this one CSV file. So we'll actually go ahead and be able to go and submit another one. Let's go and generate that. OK. So yeah. That is container apps, though. I promise this demo does work, but we're not going to sit around and wait for it. So I'll invite Sachi back on stage, and she can take control and talk about AKS here. OK.
Thanks, Cary. Hi, everyone. Are you able to hear me? OK, great. Just with a show of hands, actually, how many of you folks are using AKS today or have plans to use AKS in the future? OK, good number of hands. So yeah, I'll start off with the main value of AKS and Kubernetes for your containerized applications at scale, and then go into the specific requirements of AI workloads and agents that kind of require some advancements to Kubernetes, and what we have built on AKS as a platform to enhance that and really enable the deployments at scale. And then we'll highlight a key customer afterwards and invite him on stage. So our mission with AKS is to empower you to achieve more with Kubernetes. In AKS, there are two guiding principles that we follow. The first thing is to ensure that everything is deeply integrated into the Azure ecosystem and provide the best and easiest experience by design. Second, everything that we build is rooted in open source. Whether that's pulling in mature projects that have kind of been developed in partnership with Microsoft and other ecosystem partners, community members within the Cloud Native Compute Foundation or the CNCF, and pulling that into a managed experience on AKS, or us actually introducing new projects as a differentiator in certain spaces such as AI and GPU, and donating that to the CNCF and collaborating with the community. We've deeply invested in open source from both of those perspectives. As a service, we're also investing into these 6 areas that are presented here on screen, which ranges from capacity, resiliency, performance and scale, developer productivity, security, and cost optimization. So whether you're helping your customers build AI-powered solutions, migrating legacy apps, or continue their cloud adoption journey, AKS provides the foundation and the tools to help you and your customers move quickly and confidently. And we'll highlight some of the foundational aspects that are required for AI at scale on Kubernetes. And with regards to control and orchestration of your AI, we're making it easier. So as use case for LLM inference specifically, and other workloads at scale mature, you'll often need more control and orchestration. And that can be with regard to control over your GPUs, your accelerators, or compute, stateful orchestration, or just complex data flows and pulling in multiple different sources of data efficiently and in regular patterns. AKS provides full Kubernetes capabilities, including custom scaling policies, now advanced scheduling and integration with your AI pipelines, and is the platform of choice for, we'll go into a use case for retrieval augmented generation, multi-component pipelines, and traffic shaping across models. And with the foundation, it definitely cannot always be simple with selecting your GPU SKUs. What is the optimal compute for, let's say, the size of the open source models that you're working with, scaling those models, configuring your taints and tolerations, and ensuring that your GPUs, your accelerators under the hood are configured successfully and quickly. So a feature that we've introduced on AKS recently is in public preview, it's simplifying your GPU node pool creation. So across all of the supported GPU types on AKS today, you'd now be able to use this public preview feature to provision a GPU node pool in just one step. And we definitely had heard feedback previously from GPU customers in that it was a bit disjoint, the process previously in AKS managing the drivers, but having to self-deploy the device plugin and really ensure that those GPUs became schedulable and were ready to accept those workloads. And that is what we took into making this feature a lot simpler. So this experience now installs the drivers, device plugin, and metrics exporter for a range of NVIDIA GPU types, ranging from your A100, H100s, H200s, and more, and significantly reducing that operational overhead as you're managing not just one GPU node pool, but maybe several different types of GPU node pools, even across several AKS clusters. And when it comes to managing those GPUs, we definitely wanted to give more insight into the health of the underlying compute through the AKS layer and leveraging an existing feature called Node Problem Detector, or NPD, that existed in AKS as a generally available feature. What we introduced into NPD was a suite of health checks that continuously monitor your GPU nodes for supported GPU types at this time. And they check for the most critical errors that we've seen across our GPU customers and their AI pipelines at scale. That ranges from XID errors, NVLink status errors, and even more. And if detected on these GPU types, it would set a node condition accordingly to prevent new workloads from being scheduled onto those nodes and really help you kind of reroute your workloads to the healthiest GPU nodes within your AKS cluster. So ultimately, boosting reliability and reducing resolution time for your production AI deployments. In multi-GPU or distributed deployments, DevOps teams may notice only when the performance drops or when user feedback rolls in, which can be a bit too late. So this feature is definitely helping proactively detect for GPU failures that may impact your AI pipelines. And with the topic of workload placement and kind of leveraging scheduling policies on your AKS cluster, we've also introduced in public preview configuration of the scheduling behavior within your cluster. So previously, the AKS scheduler and the Kubernetes scheduler more broadly was designed for your microservices, and on AKS, it was kind of like a standardized process across your different workload types. Well, AI workloads themselves can vary. You can be working with batch data processing jobs, real-time inference, GPU-intensive pipelines, and all of those might require different types of workload placement. And the default Kubernetes scheduler did not always have the workload-specific intelligence for queuing, for priority-based scheduling, et cetera. So with this feature, you can define scheduler profiles, which pull in Kube scheduler plugins and would be able to iteratively define the scheduling behavior that you would prefer on select node pools or as a default across your entire AKS cluster. And it's essential as a tool for your infrastructure as it grows in breadth and complexity. And kind of pulling in all of these concepts together, we do want to highlight an open source project called 𝗦𝗽𝗲𝗀𝗏, or the Kubernetes AI toolchain operator, which we introduced recently and have worked with the CNCF to make it a CNCF sandbox project and collaborating with the upstream community in developing this project. So 𝗦𝗽𝗀𝗀𝗏 helps you build, iterate, and power your AI apps faster on Kubernetes and on AKS so that your developers can focus on innovation and your platform admins do not have to maintain different types of disjoint infrastructure for all your different types of AI workloads. It helps you automate entire AI workloads in minutes, ranging from inferencing, fine-tuning, and now recently to retrieval augmented generation, or RAG, and really helps enable that faster iteration between your developers and operator teams. So 𝗦𝗽𝗀𝗀𝗏𝗏 itself is an operator, and it automates a range of different AI workload deployment processes on your Kubernetes cluster. And these are some main points that really accelerate your time to value when it comes to experimenting, taking from prototyping with open source AI models to your production environments. So kind of the key value points for 𝗦𝗦𝗀𝗏𝗏 and for the managed experience on AKS is container-based model management, really packaging together all of the model artifacts, the dependencies that you need, and optimizing the choice of compute that it's deployed onto to really avoid those costly GPU out-of-memory errors and other setbacks as you're building out your AI pipelines. It defines these preset configurations within 𝗦𝗦𝗀𝗏𝗏 workspaces with just a few lines of YAML code, and support a range of multiple runtimes, auto-provision your GPU compute under the hood, and preparing it for the AI workload that you're going to deploy, and now supports MCP and tool calling with the VLLM runtime under the hood. So double-clicking a bit on our support for retrieval augmented generation, this is now supported in the open source project, and it really helps you operationalize inference with infra-aware and containerized document retrieval. So when it comes to your RAG pipelines and those architectures, you could be working with a range of different frameworks and tools. That might be your vector databases, your embedding models, your inference model itself, and tying all of those together in a repeatable pattern is not as clear sometimes on Kubernetes. So what 𝗦𝗦𝗀𝗏𝗏𝗏 does is consolidate your most popular open source frameworks for each of these individual tools for RAG, leveraging Facebook AI similarity search, or FIAS, and a range of other common frameworks, and pulling them into 𝗦𝗦𝗀𝗏𝗏𝗏 workspaces. So we definitely encourage you to try that out and see how it can accelerate pulling in different data sources, whether those are actual like code samples from your code repositories or large text data, in making your LLMs, your open source LLMs, more context aware at scale on AKS. And coming soon, we do have 𝗦𝗦𝗀𝗏𝗏𝗏𝗏 support in the AKS portal. So that really means just one-click inference and observability with the supported models with 𝗦𝗲𝗀𝗀 today on AKS, managing that much more seamlessly across your AKS cluster or multiple AKS clusters, and enabling your different teams within your organization. So that could be your developer teams, your data science and platform engineering teams to collaborate in this unified interface. And they should have consistent, secure deployments for AI and ultimately reducing operational burden. Within the upstream project as well, we also have support for inference traffic management. And this definitely comes into play when you're working with different types of models, different complexity of open source large language models, and you want to optimize and ultimately route your user requests to the right model that you want to serve it. Or let's say you were to tier certain models based on the complexity of the requests, you'd be able to do so by leveraging the Gateway API and the inference extension that's associated with it in Kubernetes. So this is now supported with 𝗦𝗀𝗀, leveraging the Istio support for Gateway API inference extension. And kind of pulling this all into a demo that represents actually your experience at this conference at this kind of scale here at Ignite. We're going to demo an event game plan on AKS and mainly show kind of the architecture of how you can pull together all of these features and build like a production-ready, useful application on AKS. So let's see, we're at this conference. We want to optimize our experience here, and we want to attend, let's say, the certain sessions led by like a specific Microsoft team, or attend AI-related sessions, and we want to make sure that as we're planning out our schedule, that we have enough downtime in between and can realistically get from place to place as we're attending this conference. So building actually this architecture using the features that I listed previously, this is what a sample event game plan could look like on your AKS cluster. So if you're interacting with your Kubernetes application and you submit a request, you essentially want to be using a gateway to route your request to a specific model, and you could be using RAG Engine to pull in information from the public event schedule and keep it more informed, more up to date on, let's say, that event locations have changed or timings have changed, and you want to ask your app quickly, what is the next session on this topic that I can realistically attend with the time that I have, and pull in that information efficiently from the schedule itself. You could also route it to other models for inferencing and kind of separate by workspaces within your AKS cluster for more organization of your deployments, and essentially pulling in the most context-aware models when needed. So that was kind of a sample architecture of all the features built on top of the foundational kind of GPU elements that GPU and AI features that we've introduced onto AKS and support for your production deployments. And we do want to actually highlight and give a spotlight to the Royal Bank of Canada, or RBC, and Mehrdad has joined us here today to discuss sample architecture that they've built out and how they're leveraging 𝗦𝗀𝗀𝗀 on AKS as well.
Thank you so much, Sachi. So I'm Mehrdad from Royal Bank of Canada. Royal Bank of Canada, RBC, is top one in Canada in AI maturity and among top 3 globally in that field as well. So that's not by accident. We have thousands of applications, app team developers in the bank, and they want to leverage AI solutions rapidly and having a speed to the market for the AI solutions and financial solutions, including risk modeling, fraud detection, infrastructure management, generating loyalty offers. So they need that AI model to be hosted privately by following our risk and compliance model. Because in the bank, our bank is highly regulated. And because of that, we cannot just have our OpenAI models running publicly somewhere else, like even on Azure OpenAI. We need to keep the model internally safe because of those regulations. And because of that, we need to, but at the same time, the app teams want to have flexibility to get the GPU resources dynamically and fast, not just waiting months that someone goes and buy their GPU resources from on-prem services and then set up that. That's why we are offering our CI/CD pipeline as a self-service automation, and they can get their GPU resources in a minute. And that follows all of the risk and compliance regulations that we have. And at the same time, we are offering a speed to the market in a good way and in good shape as well with good metrics. As you see here, there are many app teams working together in the bank, and they all want to, using our self-service CI/CD pipelines. Through that self-service CI/CD portal, they can just put their YAML files, whatever the CRDs that are related to K2 operator. They just send those CRDs through that CI/CD pipeline, and it comes to our control plane. Control plane enriches those manifests by adding the risk and compliance attributes that is required for the platform, and then even it controls the quota. So we don't want the app teams to compete and consume all the GPU resources available in that namespace or in that cluster. And then we push the enriched and finalized version of the CRDs, including K2 CRDs, to a Flux operator, and then push it to the target cluster. And as you see here, it's not only K2 CRDs that we are deploying. We are deploying the other Kubernetes resources that they have, including deployments, ingress, service config map, and the other type of CRDs. And it comes together as a package with K2 CRDs too, including rack system, workspace CRDs. And then we bind it automatically to their past services like Azure Key Vault and Manage Identity for the other extra steps that they need to do for the other operations that they have. We secure the environment, the namespace, and the workload. And then K2 schedules those pods on their own GPU node pools, which was provisioned automatically in minutes. So by that, we are just offering an innovative solution, but at the same time following our risk and compliance regulations at the same time as well. So yeah, that's what we are offering, and all of our app teams are happy about that. And we are expanding that to the other solutions that we are thinking about to offer to the app teams, including loyalty offers, processing mortgage documents, and the other use cases as well.
Yeah, thanks for going into that architecture a bit more and the use cases. We'd also like to learn, so as RBC is investing in more AI projects, how is Kaido and maybe AKS more broadly helping consolidate the different complexity of AI workloads That's
a good question. So RBC is building the biggest AI farm in Canada. We are exploring all opportunities that we can have that AI farm expanded to all app teams that we have in RBC. But as I said, at the same time, we need to follow our regulations and risk compliance rules. One challenge that we have is if we want to host our AI models externally, then we have to pay a lot for traffic egress as well. So we want to fit the AI model next to the actual workload and client application, so they can just call the AI model endpoints internally and reducing the network latency as well. And then they all can manage one namespace on a single pane of glass through our control plane and monitoring systems too. So reducing the networking latency, reducing the cost, and also reducing the risk that a public endpoint can expose to the application are the benefits that we are getting with this model. And thanks to the K2 project for offering this solution to us.
Yeah, thank you for joining us today. I feel like we learned a lot about this use case and architecture, and we'll close out here for the remainder of the session. Do you want to join me, Cary? Sorry.
No.
So just some key session takeaways on AI models on Azure. So when you have these different options here for containerizing your open source models at scale, there are different considerations and different offerings for all of these solutions. So with AKS, you have this level of flexibility on your compute sizes with strong foundations that you're building off of, but leveraging those open source benefits, the scalability, speed and flexibility, data governance, as we kind of discussed with Mehrdad as well, and flexibility to auto-scale based on a range of different metrics and build your production deployments at scale.
Yep. And from the Container App Serverless GPU side, a lot of what Sachi just went over is exactly the same, honestly.
Yeah.
We share a lot of the benefits there, being in the open source space and being a platform hosting these containerized applications. One thing that I think that we are adding on top is the serverless scaling with pay per second pricing for our VSLMs, right? We're really focused on burst scaling and pay per second pricing. Yeah.
Okay, so yeah, just closing out here, these are some key resources for the features and the announcements that we mentioned here today. And we can discuss any questions that you have, kind of open up to a Q&A now.
Yeah.
Are you not going to show us what is the result of the...
Oh yeah, we can do that.
Would you like to see that? Yes, thank you. He's giving me a chance at redemption. Only I stood away from the computer for so long that maybe we'll see. Let me try.
Is it switched over?
It is now. Okay, well, I just ran another one. Let me kick this off. Should. All right. Well, it looks like today it's not liking me.
Could be a Wi-Fi.
He gave me a chance at redemption, and then didn't take it. But it's supposed. I can show you what it's supposed to look like, actually, if that is of interest. Only we'll have to see which one is. I think. Nope, not that one. There are. I think we got. Yeah, there we go. This is basically what was supposed to come out of it, but you gave me a chance of redemption. Didn't happen, but that's what it's supposed to look like. Yeah.
Okay. Thanks again, everyone, for joining the session today.
Yep.
And we can, answer questions you might have about ACA, AKS
Yep.
for AI on the side.
For sure.